Welcome to section 2.6, day 1, solving nonlinear inequalities. Now, today's our objective is to solve nonlinear inequalities. So solving nonlinear inequalities. When we solve nonlinear inequalities, the zeros divide the x-axes into intervals of positive or negative range values. So our y's are negative or positives. We use the zeros and a sign chart to solve these nonlinear inequalities. And sometimes it does help to have a graph, so I'm going to show you what the graph looks like as we do this. So the first thing we do with this nonlinear inequality we have of x squared minus 8x plus 16 is less than or equal to 1. So we're going to get everything on the left side, so it's 0 on the right. So I have to subtract 1 from both sides, and I get my quadratic, x squared minus 8x plus 15 less than or equal to 0. From here we do our normal solving techniques. We are going to factor it. So x minus 3, x minus 5, less than or equal to 0. So our solutions from this are 3 and 5. So this is where it crosses the x-axis. Now we want to know is when our y values that we have are either positives. In this case we want to be less than, so we want to see where they're negative. Now that we have our solutions of 3 and 5, we want to see where it will fulfill this inequality where our y values are less than 0, less than or equal to 0. So one of those things we can do is we can make a sign chart. We could graph this as well. So I'll show you the graph so you can see a visual of what's happening. And sometimes when you do these, it does help to graph them, at least to draw a sketch of the graph, although it is not required unless it says to do so. Well, if we use a sign chart, we have 3 and 5. We know the end behavior of this. This is a quadratic. The leading coefficient is positive, so our end behavior is positive on the ends. So we know that both sides are going up to infinity. That means down here we are below and we have a negative. And if you need to with these, plug in 4. You can plug it into the original, or you can plug it into this one, or you can plug it into here and see what happens. You have 4 minus 3, you have 4 minus 5. Sometimes it is easier to use the factored form. And we have a positive 1 times a negative 1. And we're actually going to look at this when it's equal to 0. We just want to see what the sign is here. And we have a negative 1 on the left. That's where I get this negative sign right here. For a lot of these, if you know the behavior of the function, using the end behaviors will help you fill in the rest of the sign chart. And the sign chart will show you where our solution area is. We want to be less than or equal to 0 when we wrote this. We want to be negatives. So our solution in this case, and you have to be careful with these, is we have the equal bar in there, so the zeros are included, so we need brackets. And this is my solution area. This is my solution interval from 3 to 5. And if you look at the graph, you'll see that between 3 and 5, we are below the x-axis. We are less than or equal to 0. This is all we're going to do to solve nonlinear inequalities. You do not have to graph them if you understand the end behaviors using a sign chart, but sometimes it might be helpful to draw a sketch. So solve using end behavior and a sign chart. Again, first thing we have to do is get everything on the left side. We're going to subtract 3x squared. We're going to add 24. We're going to subtract 3x squared. We're going to add 24. We get x cubed minus 3x squared minus 22x plus 24 greater than 0. So we have this cubic. Well, we can use a sign chart to help us out a little bit. And if we understand the behaviors of this, it will help us out. So setting up my sign chart. We don't know what's going to happen in the middle yet because we don't know what our solutions are, but we know because it's a cubic and the leading coefficient is positive that we're going to start at negative when we're at negative infinity, and we're going to be going to positive when we go to positive infinity. We do know this. We do need to see if we have any zeros or not, because if we have multiplicity, it won't cross the x-axis when we have multiplicities of 2 or 4. So we have to look for those. So we do need to find out what our zeros are. And this goes back to what we've been doing before. We need to find our rational zeros and see if we can find something. I would recommend here, you could also use Descartes' rule of signs. It will help you know what type of solutions we should be looking for. So if we just do the Descartes rule of signs, we have a sign change and a sign change. We have 2 or 0 positive real zeros. And if we check for negatives, we'd have, I'm just going to do it f of negative x. We're just looking for sign changes. So negative x cubed minus 3 negative x squared minus 22 negative x plus 24. And we get negative x cubed, we get plus 3x squared, we get plus 22x, and plus 24. We have one negative real zero. So there's a sign change here, and that is it. So we know we have a negative solution. We know we are going to cross at the negative. Let's see if we can find the negative solution. So we're going to use our rational zero theorem. We have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. And we look for one that we think would work. Again, I'm going to use somewhere in the middle, so I'm either going to use 4 or 6. And I'll use a negative because we know we have a negative solution. So let's use negative 4. And we have our coefficients are 1, negative 3, negative 22, 24. And we bring our things down here. We have 1, this is negative 4, negative 7, multiply, get 28, this is 6, this is negative 24, we get 0. So we know we have this. We have x squared minus 7x plus 6. And if we factor this further, we have x plus 4, x minus 1, x minus 6. Those are my zeros. So we know we have a negative 4, we know we have a 1, and we know we have a 6. We know that we cross at these points because they're not multiplicities. They're just one solution at negative 4, 1, and 6. So we know we cross. That means this has to be positive. This has to be negative because we're crossing. We know we cross. We have to change signs when we cross the x-axes. All right, so that's our first part. Now we just see where our solution is. We want to see where we are greater than 0. Where do we have positive signs on our sign chart? And this time we just have the greater than symbol. There is no equal bar. So we do not include the zeros. So it's negative 4 to 1, union 6 to infinity. This is my solution for this inequality. All right, this is how we approach these. You don't have to graph them. We use sign charts, look for zeros, and we just use a sign chart to solve them. Let's look at a couple more. Here we have x squared plus 12x plus 36 is greater than 0. We can factor this. This is a perfect square trinomial. So we have x plus 6 squared greater than 0. So we're going to look at our end behaviors. We have an x squared. So we have an even power with a positive leading coefficient. So we know our end behaviors go to positive on both ends. Then we know we have a solution at negative 6. But this has a multiplicity of 2. So it does not cross the x-axis at negative 6. It just touches the x-axis. So as we come into negative 6, we're just going to touch there, and then we're going to stay positive. We do not change signs there because of the multiplicity. The vertex is actually sitting on the x-axis at negative 6. We do not have a sign change there. It only wants when we are greater than 0. Well, at negative 6, we are not greater than 0. We are at 0. So for this one, it has an unusual solution set because we go from negative infinity to negative 6. But negative 6 is not included because we do not include the zeros. And then from negative 6 to infinity. This is where it's above the x-axis everywhere but at the 0, negative 6. If we would include the equal bar, we would have all real numbers Be careful with this when you're doing different ones for solutions. Make sure we don't have any multiplicities. If we have multiplicities, you have to be careful on what your inequality is telling you to do, because at a multiplicity of 2 or 4, we are just touching the x-axis. We do not cross the x-axis. All right, here's some more that have unusual solution sets. If you look at this, it's the same equation basically, except for one is greater than or equal to 0, and the other one is less than or equal to 0. These are not factorable. So there's two different ways you can approach this. You can use a quadratic formula, or you can find out where the vertex is, and it'll tell you if the vertex is above or below the x-axis, which is what we need to know. If we do the quadratic formula, you'll find out if we have any solutions, but you can do it either way. So I am going to find the vertex, because this is not factorable. So I'm going to do x is -2, remember the opposite of b, over 2 times a, which is at -1. If we plug -1 back in, we have -1 squared plus 2 times -1 plus 3. And we want to see where this is going to, so we're actually just looking for f of -1. You have 1 minus 2 plus 3. That's 4 minus 2, which is 2. So our vertex is at -1, 2. And if you look at this, I'm just going to draw a sketch because it does help. Our vertex is up here. We know that we open up because we have an x squared, and it's not -x squared. So we know we open like this. This we know. So this shows us that with this greater than or equal to on the left side, we are always above the x-axis. So this one has the solutions are all real numbers. Or you could do the interval from -infinity to infinity. It's up to you. When you have the other one, it says it's less than or equal to 0. Well, for this one, it never is below the x-axis. We are never having negative y values. So we are never having a solution. So this is no solution. You could also give me the empty set symbol, which is the 0 with the slash through it. So no solution. So be careful with these. Sometimes you have to figure out where the vertex is, look at if it's opening up or down to see if it's crossing the x-axis or not. If this was opening down, you would have to use your quadratic formula to find out where you are crossing. And you would have some radical answer because it's not factorable. All right, so this is some things you'll run into where you have unusual solutions, where you have all reals, no solutions. You might just get if the vertex is on the x-axis, you could just get the actual number on the x-axis depending on what the inequality says. So be careful with your inequality symbols and what it's asking you to find. You do not have to graph these. You can just use sign charts. Like this one, we couldn't use the sign charts. We had to figure out what the vertex was. But if you can use a sign chart, use it. It saves a lot of time. All right, that is all for 2.6 day 1. Today we solved nonlinear inequalities by using what we know about end behavior and finding zeros and using a sign chart. Thank you for watching and have a nice day.